Hey guys, it's Coffee with the little tutorial here. This is my first video, and in this video we're going to explore the geometric meaning of determinant of two vectors in two dimensions. Now many of you knows how to calculate the determinant of a1, a2, b1, b2, two vectors. So the determinant of a1, a2, b1, b2 is just a1, b2 minus a2, b1. And this will give you a number. Well, I assume that you know what this means, this matrix. Is actually like two vectors, a1, a2, and b1, b2. And determinant, to take the determinant of these two vectors, write in the form that a1, a2, b1, b2. And in this case, each of these are just numbers, and you take them into here, so of course you will get a number. So determinant of two vectors give you a number. Now what this number means, well, let's dive a little bit deeper here. So the determinant of vector a1, a2, b1, b2 is a1 times b2 minus a2 times b1, and it can also be rewritten as the dot product of minus a2, a1 and b1, b2, right? So if you dot these two vectors, you will get minus a2 b1 plus a1 b2, which is exactly the same. So this are equivalent. Now, what if the determinant is 0, which also means the dot product of these two vectors equals 0? So this two vector is perpendicular. Now if we draw this on the graph, we get the first vector minus a2, a1, and another one b1, b2. And their determinant are 0. Okay, what if the determinant is not 0? What that number will tell you? What is the geometric meaning of that number? So now, let's make this vector a prime, this vector b. So this can be written as a prime dot b. AB is two vectors. One more thing to notice here. So the vector A and A prime are actually perpendicular. Why is this? Well, the dot product of the vector minus a2, a1, so this is A prime, and the vector A, so just weigh a1, a2. If you calculate it, it's 0. So A and A prime are perpendicular. So let's draw a graph. We have vector A prime is perpendicular to A. So let's say this is vector A. This is vector A prime. And they should have the same length. Now, I'm gonna draw the vector B here. So let's say the angle between vector A and B is theta, and the angle between A prime and B is theta prime. Okay, so let's do some calculations. So the determinant of A1, A2, B1, B2 is the dot product of A prime and B. Now we know the dot product of A prime and B is just the norm of A prime times the norm of B times cosine, in this case is theta prime. And we also can rewritten this as the norm of A, because A and A prime have the same length, right? And the rest. Now, one more thing to notice, that theta prime plus theta is 90 degrees, which means theta prime equals 90 degrees minus theta, which can also be written as radians. So pi over 2 minus theta equals theta prime. So let's rewritten this as the norm of A times the norm of B times cosine pi over 2 minus theta, which is norm of A times norm of B times sine of theta. So what's this tells you? Well, let's see. If I draw a vertical line from B to A, this part is actually the length of this line, and we name it H in this case, and times the norm of A, which we can see as a base. So what's the product of these two? What's the product of a base and H? So it turns out that the base times H is actually the area of the parallelogram. So it's this. If I move A up here, if I move B to here, I will get a parallelogram here. So the determinant of the vector A and B is just the area of parallelogram that these two vectors makes. So this is the geometric meaning of the determinant in 2 dimensions. So yeah, that's about it. Thanks for watching. See you guys next time. Peace.